Hi everyone, welcome to the Earth Science Regents Review podcast series created by Homix Middle School Earth Science Department. Today we're going to talk about page 14 in the reference table, the global wind belts diagram. Now this diagram has a multitude of features in conjunction with some of the wind belts on the planet. So let's start out with the outside convection cells. You'll see that these convection cells are going to help distribute energy from the North Pole and the South Pole, bringing energy to the equator, and bringing energy from the equator back up to the North and South Pole. Kind of keeps a balance within the temperatures on the planet. You'll see that some of your convection cells are going to cause wind to rise and for wind to sink. And that's all based upon warm air and cold air and the differences between pressure as well. And we'll talk about that in a little bit more detail later on in this podcast. You'll see that the wind belts themselves within the planet have different curvatures to them. That's called the Coriolis effect. The Coriolis effect is caused by the fact that the Earth rotates on its axis. Winds in the northern hemisphere are going to be deflected to the right, and winds in the southern hemisphere are going to be deflected to the left. So make sure you have an idea in terms of what the Coriolis effect is going to be all about. You'll see, starting at the North Pole, the winds are named from the direction in which they come from. So we're going to start out with the polar easterlies. They come from the northeast. Then we're going to move into the westerlies. Then we're going to move into the northeast trade winds. Those are all in the northern hemisphere. In the southern hemisphere, we have the southeast trade winds. We have the westerlies again. And then again, we have another set of polar easterlies as well. Now, each one of these winds, you remember, are going to start from high pressure and are going to blow to low pressure. So winds are named from the direction in which they come from, and they're going to blow from high pressure to low pressure. Again, starting in the northern hemisphere, the cold air at the North Pole is very dry, so it's going to be very dense and it's going to cause it to sink. Winds along 30 north, they're going to be very dry as well. Again, high pressure here, winds are going to sink. You notice that the winds are diverging. Once they sink to the surface, they're going to diverge. They're going to spread out in all directions. Winds at 30 south do the exact same thing. Again, very dry air, high pressure here. Okay, you're going to notice that the winds are diverging. And same thing with the South Pole, very dry air, very cold at the South Pole, winds are going to sink. Now, anywhere where you have dry air that's sinking, high pressure that's sinking like this, you tend to have deserts. So even though the North Pole and South Pole have a lot of ice and snow, they're considered polar deserts. 30 north and 30 south, that's where the majority of our deserts are going to be found as well. Well, you put that in conjunction with the low pressure centers, which are going to cause air to rise. They tend to be very wet. So 60 north, you have converging winds causing warm air to rise, cool to the dew point, and you're going to get precipitation. You're going to get this a very, very prominent feature at the equator. That's where all of our tropical rainforests are going to be found. Warm air is going to converge, going to cause it to rise up, and you're going to get tremendous amount of precipitation. You also get that at 60 south as well. So you can see at the different zones, you can tell whether or not you have high or low pressure based upon not only if it's dry or moist, but whether or not that air is going to rise and sink. So this global wind belt diagram is very, very important regarding some of the different locations on the planet in conjunction with air rising, air sinking, and the moisture content within it. So that's it for now. Thanks so much. We'll talk to you soon.